From the earliest streaks of dawn to the radiant glow of sunset, moving steadily from east to west, the sun, majestic day star of the cosmos, catalyst of life, source of light, heat, and energy. The high-tech challenge of solar energy is to generate electricity from sunlight. Standing on the frontier of sun-generated electricity is the Vanguard. Project manager of the Vanguard is Byron Washam, president of Advanco Corporation, a small business in El Segundo, California, and prime contractor of the Vanguard.
The Vanguard is a 25 kilowatt electric parabolic dish generating electricity by using a United Stirling power conversion unit at the focal point. What this module will do is take the sunlight and convert it into mechanical energy and then into electricity. Remember, as a child, we all played with a magnifying glass and a leaf, and we would burn a hole in that leaf. Well, what we were doing is we were taking the sunlight and concentrating it into a superheated focal point. In principle, we do the same thing with this parabolic dish module. Let's now go and look at the different components that makes this possible.
Vanguard's magnifying glass is the parabolic dish concentrator. It has a diameter of 11 meters and consists of 336 mirror-like facets. These facets are made of a highly reflective back-silvered glass attached to a foam glass substrate with a slight spherical curvature. The facets are mounted on 16 racks, ensuring a sturdy and accurate reflective surface under various wind and gravity loads. Each facet is optically aligned using a computer-generated target and a 1,200-foot collimated light source. When all 336 facets are aligned and the concentrator is on sun, the Vanguard concentrates the sun's radiant energy 2,700 times, creating temperatures at the focal point up to 6,000 degrees Fahrenheit, making the Vanguard one of the greatest concentrations of sunlight on the face of the Earth. A piece of quarter-inch stainless steel placed at the focal point would vaporize instantly. To maintain these high temperatures, the dish must accurately track the sun. The problem facing Vanguard's designer was developing an efficient tracking system with low power consumption.
Energy efficiency is not only important in the production of electricity, but it's also important in the consumption of electricity. How much parasitic power is being used to drive the system? Less than 8% of the electricity produced is used to drive this module, making it 92% efficient.
The unique solution was the exocentric gimbal mechanism, EGM. The EGM rotates rather than lifts the center of mass. This maintains the center of gravity in a horizontal plane, eliminating the torque which would be required to lift the 8.5 tons of equipment, including the 3/4-ton engine cantilevered at the focal point. The EGM maintains a tracking accuracy of 3/100ths of a degree and consumes very little energy to operate. Tracking and monitoring of safety functions is the role of the Subconcentrator Control, SCC. The synchros are used on 2 exocentric gimbal axes to report angular position. Sun position is determined by a solar sensor. The SCC analyzes the data and executes the necessary tracking movements to follow the sun from sunup to sundown. Vanguard incorporates the most advanced technology available. Solar radiation striking the dish is focused through an 8-inch diameter aperture in the solar receiver, which is suspended at the focal point 20 feet above the dish. The power conversion unit is built around a United Stirling of Sweden Mach II solar engine. The Stirling is an external combustion engine. The Stirling engine converts heat energy to mechanical energy by alternating compression and expansion of a confined high-pressure hydrogen gas. The pistons are moved back and forth between the hot and cold locations of the engine, transmitting mechanical work to the drive shaft, which is coupled to the electric generator. This external combustion engine is well suited to the demands and image of solar energy. It is silent, virtually vibrationless, consumes no lubricant, and emits cool, clean exhaust gases. It may well be the engine of the future. The remaining key subsystem is the electrical power subsystem. The induction generator within this system converts the output of the power conversion unit to electricity. The EPS controls the flow of electricity from the Vanguard to the electric grid. Let's examine the operation of the Vanguard. When the module is on sun, solar radiation strikes the mirror facets and is focused into the receiver. The receiver is coupled to the Stirling engine. The engine converts the heat energy to mechanical energy, driving the generator, creating electricity. The electricity is sent through the control systems to the substation for use by homes and businesses. Economies of scale can be obtained by clustering up to 32 dishes together in a concentrated grouping. This will allow for the generation of up to 800 kilowatts of electricity. The Vanguard was designed and tested under a cooperative agreement between the Department of Energy and Advanco Corporation. At the outset of the Vanguard program in May of 1982, parabolic dishes were a poorly known, highly experimental solar technology. Vanguard has proved parabolic dish technology to be highly efficient and cost-effective. Vanguard's performance has exceeded expectations and, in fact, has set 8 technical world records for efficiency of converting sunlight to electricity. The Utility Research Panel hailed Vanguard as a substantial and important step. Research and Development magazine recognized Vanguard as one of the 100 outstanding technical innovations of 1984.
This past year of testing of the Vanguard module has indicated that each dish is capable of producing 56,000 kilowatt hours of electricity. This is enough to power approximately 15 homes. It converts, on the average, 23% of all the sunlight that falls on this dish's area into electricity.
The highly successful Vanguard module is the precursor to designs that will someday be operated by public utilities, industrial and commercial buildings, and large residential developments. Its advantages include the generation of clean and efficient electricity from sunlight, the ability to increase capacity in small incremental additions, and the Vanguard technology requires little debt service prior to operation. At its test site near Palm Springs, California, the Vanguard has been in operation on sun since February 1984. Each day it tracks the sun across the desert sky, it comes closer to being a major new source of electricity. The engineers who designed Vanguard understand the perils of energy amnesia. They realize the magnitude of energy available to those who can harness the power of the sun, and they know the success of standing on the leading edge of technology with Vanguard.